In the spring of 2022, America's most effective weapon in Ukraine wasn't a fighter jet or a warship. It was a shoulder-fired missile called the Javelin. Inside each one, roughly 250 semiconductors, guiding it to its target. Welcome to BBTV Intelligence Briefing. Today's question: how did a fingernail-sized sliver of silicon become more strategically important than oil? The answer runs through one company in Taiwan, one machine built in the Netherlands, and an economic war between superpowers that has already started, without a single shot being fired. Ukraine burned through them faster than American factories could replace them, and every replacement depended on chips from an ocean away. And here's the detail that should stop you cold. Almost every advanced chip like these traces back to a single island 100 miles off the coast of China. One Taiwanese company alone manufactures roughly 90% of the world's most advanced chips. The machines it depends on come from exactly one company in the Netherlands, and the software used to design them comes almost entirely from the United States. 3 choke points, 3 countries, one supply chain, the entire modern world. Every phone, every car, every missile depends on. Which is exactly why chips have stopped being just a product and started being a weapon. By the end of this briefing, you'll understand how semiconductors became the oil of the 21st century, and why the war over them has already started without a single shot being fired. Here's the state of play right now. The Taiwan Semiconductor Manufacturing Company, TSMC, produces roughly 90% of the world's leading-edge chips. The processors inside flagship phones, data centers, and artificial intelligence systems. That's a level of concentration with no parallel in any other strategic industry. Not oil, not rare earths, not even nuclear fuel. Its most advanced factories sit clustered on the western coast of Taiwan, inside range of thousands of Chinese missiles. A single earthquake, blockade, or missile strike, there wouldn't just disrupt an industry, it would freeze the world economy in place. Every one of those factories depends on a machine called an EUV lithography system, extreme ultraviolet, which etches transistor patterns thousands of times thinner than a human hair. Only one company on Earth can build that machine. ASML, headquartered in the Netherlands. In October 2022, Washington turned this supply chain into a weapon. Sweeping export controls cut China off from advanced chips, the tools to make them, and even the American engineers helping build them. Officially, the target is China's military modernization. In practice, the controls reach deep into its civilian economy. Data centers, smartphones, and the artificial intelligence models built on top of them. Japan and the Netherlands joined within months, closing the loop on nearly every machine that matters. To understand how much this hurts, consider one number. China spends more money importing chips every year than it spends importing oil. Most years, that bill runs north of $300 billion. Not weapons, not aircraft, chips. And unlike oil, there is no alternative supplier, no strategic reserve, and no substitute. The strange part is that America invented this entire industry and then gave the most important piece of it away. The transistor was born at Bell Labs in 1947. The integrated circuit followed in the late 50s out of Texas and California. Chips built the Apollo guidance computer and the first precision weapons. The Pentagon was the industry's first big customer. For decades, silicon meant Silicon Valley. In 1990, more than a third of the world's chips were manufactured in the United States. Today, that number is closer to 1/10. What changed was a business model. and one man. In 1987, an engineer named Morris Chang passed over for the top job at Texas Instruments, founded TSMC in Taiwan, with heavy backing from the Taiwanese government. Taiwan's government wasn't gambling on chips as a business, it was gambling on them as survival, a way to make a small island indispensable. His insight was radical at the time: a factory that designs nothing of its own and simply manufactures chips for anyone. That foundry model let American companies stop building factories, which had grown brutally expensive, and just send designs across the Pacific. A leading-edge fab today costs around $20 billion, more than a nuclear aircraft carrier, and the cost curve only climbs. Every new generation of chip roughly doubles the price of entry. So one by one, almost everyone stopped. Intel stumbled, the Japanese giants faded, and manufacturing concentrated on one island. By the 2010s, only 3 companies on Earth could still manufacture at the leading edge, and only one did it for hire. Meanwhile, the machine everyone would come to depend on took nearly 3 decades to build. EUV lithography consumed billions in research money and outlasted every company that attempted it, except one. By the time the world noticed, the entire digital economy rested on 2 single points of failure. One company in Taiwan, one in the Netherlands. Here's the part most coverage misses. The chip war isn't really about phones or laptops. It's about who gets to set the ceiling on a rival's military and economic power for the next 20 years. Taiwan understood its position early and gave it a name: the Silicon Shield. The logic: if the world's most important factories sit on your soil, the world cannot afford to let you fall, and your adversary cannot afford to destroy you. It's deterrence, without a single missile. The shield isn't military hardware, it's market share. It's why some analysts call TSMC the most strategically important company on the planet. Courted, subsidized, and quietly planned around by both superpowers. Washington's export controls flipped that same logic into an offensive weapon. For the first time since the Cold War, the United States used its position in a civilian technology to deliberately freeze a rival's progress. The controls don't just block chips, they block the machines that make chips, the parts that maintain the machines, and the people who know how to run them. American citizens working inside China's chip industry faced a choice: stop or face penalties. Nearly everyone left. Overnight, decades of accumulated engineering experience walked out of China's most advanced fabs. China's answer has been a state-directed sprint for self-sufficiency, funneling tens of billions into domestic champions like SMIC and Huawei. Beijing has poured well over $100 billion into state semiconductor funds, with results ranging from real breakthroughs to spectacular corruption scandals. And it has scored real points. In 2023, Huawei shipped a smartphone with a domestically made 7-nanometer chip that American controls were supposed to make impossible. But there's a catch the headlines missed. Without EUV machines, China makes those chips on older tools, at far higher cost and far lower volume. Estimates put China's advanced chip yields far below Taiwan's. Every chip costs multiples more, off lines that can't feed a mass market. Sanctions rarely stop a determined state. What they do is impose a tax measured in years and billions, which is why both sides now treat semiconductors not as trade, but as strategy, because that's what they've become. This is where it gets interesting. The part that connects one machine, one subsidy race, and the production line behind every modern weapon. Technology. A single EUV machine weighs about 180 tons and contains over 100,000 parts. Shipping one takes dozens of crates and multiple jumbo jet flights, and each one costs up to $200 million. ASML sells only a few dozen of them a year, and every single one is spoken for years in advance. The light source alone fires a laser at droplets of molten tin 50,000 times a second to generate light that doesn't naturally exist on Earth's surface. No machine in human history concentrates this much irreplaceable knowledge in one supplier. Economics. Washington's CHIPS Act put $52 billion on the table to pull manufacturing home. Europe, Japan, and India have followed with subsidy packages of their own, a global bidding war for factories. TSMC alone has committed to spending well over $100 billion on new factories in Arizona. It found that building the factory in America was the easy part. Staffing it with engineers was not. And here's what the subsidies can't buy: the leading edge. The newest process nodes still arrive in Taiwan first. The shield stays home. Military. The Pentagon's most advanced weapons are chip-dependent to a degree few realize. An F-35 flies on hundreds of specialized processors. The Pentagon quietly runs programs to secure trusted chip supplies for its weapons, because it too buys most of its silicon from the same commercial fabs as everyone else. During the pandemic chip shortage, car makers lost over $200 billion in a single year because of missing $5 parts. Now run that same math on a war. A conflict over Taiwan wouldn't just interrupt luxury goods, it would halt the production line of modern military power itself. That's the hidden layer. The world's arsenal and the world's economy share the same single point of failure. And everyone in Washington and Beijing knows it. So, where does this go? The map is already being redrawn. New fabs rising in Arizona, Ohio, Japan, Germany, the biggest reshoring push since the Second World War. But leading-edge manufacturing takes half a decade to move, and a workforce that doesn't exist yet. For years to come, the center of gravity stays in Taiwan. Even then, the most advanced processors will likely stay a generation ahead in Taiwan, an insurance policy Taipei has every incentive to keep. China, walled off from the leading edge, is flooding the older end of the market, the ordinary chips inside cars, appliances, and weapons, creating a new dependency nobody's talking about. American analysts warn the next shortage may come not from the cutting edge, but from those unglamorous workhorse chips, the ones nobody subsidized. Both superpowers are now spending state money at Cold War scale on the same tiny piece of silicon. Add it up, and you get the defining economic contest of this century, running on machines the size of a bus and features the size of a virus. Watch 3 Signals, where TSMC builds its next leading-edge fab, how fast China's legacy chip share grows, and whether export controls expand from chips to the tools that design them. Because the next great power war may not begin with a blockade or a landing craft. It may begin, quietly, with an export license that doesn't get renewed. Chips won't stay out of the headlines for long. Every crisis over Taiwan, every export ban, every subsidy package is a move in the same game. Control of the most important technology on Earth. This has been BBTV Intelligence Briefing. Stay sharp.